Hi everyone, so let's get started with set 3. This is question 1, so we have like some diode simplified models. So for the following diode based circuit, so we have circuit A, B, and C, we need to find indicated current and voltages using first an ideal model. So for the ideal model, I'll just quick review this with you. So for the ideal model, we just have like the diode and then it becomes a short circuit, right? Uh, for the battery model, we use the diode along with the battery. Sorry. So we can draw like the battery for the diode, and then just another diode to remember that it's placed in that branch in the circuit. So the polarity of this voltage source, like the 0.7, it's always going to be like in the reverse position as we see the diode. So one thing that can help you remember that, so always like the traces that we have here and here, they should be the outer braces that we have in this circuit. Just like a quick tip to remember how to draw. So this is 0.7. And then for the battery plus resistance model, so we keep the same battery, right? But then we also add a resistance, okay? And I want to remind you that the battery across the diode, like the voltage across the diode, is this entire voltage here, right? So we have this voltage VD here, which sums with the 0.7 from the voltage source plus the current that is flowing through this resistor. So that's the entire voltage across the diode, okay? So let's see the circuits that we have. So I won't solve all these circuits here because you see that they follow like kind of the same methodology. But for the first circuit we have just a single diode, so you can just assume it's shorted, right, for the initial analysis in all the three cases, and then you figure out that you have like some sort of current. So for the ideal diode, you just apply KCL on a single loop here, and then you figure out what's the current. Once you figure out the current, you can calculate the voltage V0. If that current is positive, right, it's flowing in this direction here, then the diode 1 is on, and then you can calculate V0. Otherwise, it would be off, and then V0 would be equals to 8 volts. But I think in all the cases, diode 1 will be on. For circuit B here, B and C, they're kind of similar. They're kind of the same circuit. We just have like a different voltage source here at the bottom. This is -8, this is -10, this is 6, and this is 20. Okay, so for this analysis, we always start assuming that the diodes, they are all on, and then we see what happens to the currents. If they are like flowing in the direction that the diode allows current to flow, they are on. If not, then they are off, and then we have to reanalyze the circuit. You'll see more on that, I think, on an upcoming question. But let's start analyzing this circuit C here. Okay. So for the first model, right? Uh, the ideal one, you see that it's just like the ideal mode and the battery model. They are just like simplified versions of the battery plus resistance model. So let's solve this more complicated one here, and then for the simpler ones you can just do it by yourself. If you have any questions, then you can contact me during my office hours, okay? But you see that they're just like simplified versions of that. So let's redraw the circuit. So this circuit C here, it's a voltage source, right, in series with a resistor here. Then we have a diode. Now let's replace this diode using the battery model plus resistance. So this is for diode 1. Then here we have the node for V0. We have another resistor here, and then again we substitute. So this is diode 1. Now we substitute diode 2 using the battery plus resistance model again. So let's put the resistor here and then the source here. and here is the ground. Okay. Sorry, we also have another voltage source down here, right? So it's not just this one. So we have another voltage source. And let me try like using a different symbol just to don't mess up with the voltage from the diode. So another voltage source here. That goes to the ground. Okay. So let's assume we have a current flowing in this direction, right? A current I. Because this direction, if we get like a positive value of current, then there is like current flowing in this direction and the diodes are on. So let's just number all the voltages and sources. So this one is 6 volts. This one is 100. This one from the battery model is 0.7, right? And the resistance RD is 20. This one here is the 60 ohm. This one is 20 again. This is 0.7 and this is minus 10 volts. So if we apply KCL in this loop here, we get minus 6, okay, plus the current I times 100. Oh, and there's another thing. So it's no, sorry, this is the updated version of the set, so we don't have that third diode. So I times 100, and then we have plus I times 20, right, from the first diode, plus 0.7 volts from the first diode, and then V naught here is just a it's connected to that branch here, so you can just proceed. There's no current flowing, right? So plus 0.7 volts plus 60 times I plus 20 times I plus 0.7 plus minus 10 volts. So plus minus 10 volts. And that should be equals to 0, right? Because we got back to the ground here. So this is the equation that we have. Now if we had the ideal model, we won't have like this term here. We won't have like for the battery model. Then we wouldn't have this term here and this term here. So we can just remove it from this equation. And if it was just like if it was like the ideal model, we wouldn't have 0.7 and then the 20 times I. And if it was like just the battery model, then we would just remove this term here and this term here, okay? But for the battery plus resistance model, we have both. So if we isolate I in this equation, then I becomes, so we have minus 6 plus 0.7 plus 0.7. So this gives us, and also minus 10, so it's minus 16 plus 1.4. This gives us 14.6, right? Divided by the sum of the resistors, so we have 100 here, 20, 60, and another 20 here, so it's 200 ohms. So this gives us a positive current of 73 milliamperes. Okay. Now, because we have V naught connected to this node here, right? And sorry, before we calculate V naught, so because I was positive, the diodes allow current to flow in this direction, so they are all on. So D1 and D2 are indeed on, right? And to calculate the voltage V naught, we can start here. We have 6 volts at this node, so we have V naught equals to 6 volts minus the drop across the 100 ohm resistor, so it's minus 100 times I, right? Minus 20 times I, right, minus, because it's decreasing the potential, so minus 0.7 volts. Okay, so if we calculate this one here, let me see how much do we get. So it is minus 3.46 volts. So those are the answers for these questions. And for the other ones, you can apply the same methodology. Just remember to take care of the resistors here and here, and the voltages here, depending on each model that you are using. Okay, and always verify if the direction that you assign for the current, it gives you like a positive value of current or a negative. If you got like a negative value of the current, then it means that it's flowing in the opposite direction. And then if that was the case for this particular circuit, then we wouldn't have the diodes on. It would be like just off. Okay.